This time, let's illustrate the image of a point in a glide reflection where we start with a translation, then followed by a reflection. We are lucky to have here that our line is actually y is equal to 7. In our high school years, we can remember that this line is actually a horizontal line because it only passes through y, which is equal to 7. So if this is our y here, 1, 2, 3, 4, 5, 6, 7, any value of x that you can think of will always get a value of y, which is 7. Hence, the graph of this is actually here. Okay, that is our graph. Okay, that is for line y is equal to 7. And this time, we are going to use the translation first of a given point. Let's say x is our identified here, negative 2 and 5. So negative 2 and 5 is somewhere here. This is our x, negative 2 and 5. So a glide reflection could be determined by reflecting that first here before translation, or the other way around, we're going to translate that in a specific direction before reflecting that on our getting its reflection on our given line L here. By the way, what would be our vector of translation? Take note that our vector of translation is parallel or proportional with the direction vector of our line here. Our line L is at 0 and is y is equal to 7. And if you can still remember, its direction vector for this is actually identified. Okay, if you can still remember, there is a specific special direction vector for horizontal and even vertical line. This is actually 1 and 0. That would mean for our translation which would follow this specific formula, we would start with the translation first of x along vector v, or using vector v before translating it to our L. Is actually identified by this. You will have your x plus your direction vector v minus twice x plus your direction vector v minus p together with our unit normal vector times our unit normal vector. Okay, this is the formula when we are to start with a translation first before a reflection. Because what is the main point here is we will take the translation as another point, similar here, and subjected that to our formula for reflection. Okay? Don't worry that if our vector v here is expressed in this manner, we can always take the translation, because the translation of any point x along vector v is just the component of your x, the first component, plus the first component of your vector. Then you will be pairing it with the second component plus the second component of your vector. So even if this is a vector and that's a point, just for the concept of translation, we can combine them. But there is other consideration here before getting the first translation or translation of the point in this formula, is that the translation must be 5 units along the line in a positive direction. Okay? So we know that it should be in this direction, but of positive 5 units. So we can actually predict that by simply jumping our point. But of course, using our concept here, vector, so simply take its multiple. So our vector v is actually identified as 1 and 0. So 5 points in a positive direction. So we are going to multiply 5 to our vector. So you will get here 5 and 0. This is the v that we're going to use here as well, not just this vector here, because we are strictly following a translation of 5 units along the line in a positive direction before the reflection. Hence, so we will start here with our translation of x along vector v. Again, it's x sub 1 plus v sub 1. V sub 1. And then you will have here x sub 2 plus v sub 2. But the v sub 1 and v sub 2 would be this, not here. Okay? In short, you will have your x is actually negative 2 and 5. So negative 2 plus you will have your 5, the first component. And then you will have your 5 plus 0. So your translation of your point x along the vector, along the line, and then 5 units in the positive direction is actually 3 and 5. When you will plot that on our Cartesian plane, you would really see the location is actually 5 units along the line in a positive direction. You will have here 3 and 5. So 3 and 5 is actually here. So we could see that it's 1, 2, 3, 4, 5 units along a positive line. So this is its translation. Not yet the glide reflection, okay? It's just a translation. So this time, we are now to proceed with our reflection in this manner. But take note, we know this to be our x plus v. So this is good. That's good. Our p is actually not yet identified in our unit normal vector. So to do that, let's talk about our p first. The p is actually any point on our line, specifically on our given line here. L is equal to line L is y is equal to 7. We can pick here the intercept or the point where the point of intersection of any axis and the line. We're choosing this one here. That's actually 0 and 7. So we're going to use that as our P. You can pick any point, okay, other than this, but since this is easier to be identified and we are more confident to have this as accurate, so let's use the x-intercepts or the intercepts if possible. Now for our unit normal vector, take note, it follows the idea of a normal vector over the length of the normal vector. When can we get the normal vector? As mentioned, it's the normal vector pertaining on this. Okay, that is actually identified as our direction vector of the line. But the normal vector is actually having the components of negative v sub 2 and v sub 1 in related to our vector v, not this one here. Since our vector v is identified as 1 and 0, so our what do you call this one? Our normal vector is negative of 0 and 1, or simply 0 and 1. By the way, these two are perpendicular to each other. So if this is horizontal, basically this is the direction vector of vertical line, and we know that already to be true. Okay. In short, for our normal vector, you will have here in parenthesis form 0 and 1, and the length of that normal vector, this one here, is the sum of the squares, and then you have to square root that 0 plus 1, so you will get here square root of 1, or simply 1. That is the length of our normal vector. So our unit normal vector, okay, is simply the same as 0 and 1, because that's over 1. Okay, so we are now sure with this. We have now P, so that we can now return to this formula, but instead of very large formula, we'll be using this. Okay, so this is now the complete form of our glide reflection. Once we know the translation first, is actually it's no longer x, by the way. Yeah, it will still be x, but we'll be treating this as 1. So you will have here your 3, 5, okay, minus, this is already the result, okay. Let's put it at the bottom because I don't have much space here. Hopefully that this page would be enough. 3, 5 minus twice 3, 5 minus your p. So your p is here, 0 and 7, together with your unit normal vector, 0 and 1. Inner product of that, again, times 0 and 1. 3, 5 minus 2. So 3 minus 0 is actually 3. 5 minus 7 is minus 2. Then you will have to take its inner product with 0 and 1. And then you will have your 0, 1 here as well. Take note that the result of this here is a scalar quantity. You will be adding the product of the components. Let's continue with the color here. 3 and 5 minus 2 times 3 times 0 is 0. Okay, plus 2 times negative 1 is negative 2. And you have here 0 and 1. So you have 3 and 5. So you're going to multiply that. So negative 4 and 0. So you will have 0. So 2 times negative 2 is negative 4 times 1, negative 4. So for the final form, this is actually now the complete image of a point in a glide reflection. 3 minus 0 is 0. 5 plus 4 is 9. this is the image of a point in a glide reflection. Considering that we started with a translation of the given point 5 units along the line in a positive direction and reflecting it to our line, which is y equal to 7. So 3 and 9 is actually here. So that's 7, 8, and 9. So basically, it's here. This is our glide reflection 3 and 9. So try to review if you would like to start with the reflection first here before a translation. We guarantee that you will still get the same glide image of a point using a glide reflection with this process starting with a translation before a reflection. Either way, this is the complete process and this is our result. Thank you very much for watching.